Today we're going to factor trinomials, and in this first example we have a trinomial that's the fourth power. So this can be factored just like we factor any other trinomial using the AC method. Even though we have a fourth power, notice that the middle term has a power that's half of the polynomial's degree. So anytime that you've got the leading power as a 4 and the middle power is a 2, we can just factor like we normally would. If this is any even number, as long as this middle term has a power that's half of the leading term, then we can do this. Okay, so what I would do, I can use the AC method. The AC method says I'm going to take A times C, and when they're talking about the AC method, we're saying that A is the coefficient of that first term, that squared term. And this can be rewritten as x squared squared, which is why they can say that this is the coefficient of the squared term. So that is going to be 1. The C is the constant. So negative 20 is the constant. So I would say 1 times negative 20, and that's equal to negative 20. And then what I would do is I'm looking for factors of negative 20 that would add up to my B value, and in this case the B value is 1 because it's coming from this part right here. Okay, so factors of negative 20 that add up to 1. So as you can see, I've listed all my factors of positive 20, but I'm looking for factors of negative 20. Since the B value is positive, that means my bigger factor is going to be positive as well. So my bigger factor would be these. These are my bigger factors. So my smaller factors are the ones that are going to take the negative, since the bigger factors are positive. Okay, so bigger factors are positive, smaller factors are negative. The factors of negative 20 that add up to 1 will be these. I'm going to use those numbers now to rewrite this middle term here. Now notice the middle term is an x squared, so when I rewrite, then my 4 is going to have to be an x squared. My 5 will also have to be an x squared. So I'm going to go ahead and rewrite this now. Alright, so I've rewritten my original expression that had 3 terms. I've rewritten it with 4 terms. And again, this middle term of x squared, if I were to combine like terms here, this would also be equal to x squared. So everything is still equal to what we started with. Now what we do is we group the first 2 terms and the second 2 terms, and when you do this, you have to have a plus between those terms. Okay, so next we're going to take the GCF out of each set of not each set of terms, but each group. We're going to take the GCF out of each group. So in our first group, right here, my GCF is going to be x squared. So I'm going to factor that x squared out. I'm left with x squared minus 4 inside. And then I take the GCF of the next group, and that's just simply going to be 5. That leaves me with x squared minus 4. Now, I see some very, very good stuff. When I factor out the GCF from each group, I'm left with x squared minus 4 in the first part and x squared minus 4 in the second part. And I call those my magic matching factors. Those magic matching factors will be one of the factors in my the factors of the original polynomial that we started with. And then the GCF, that's this part and this part that I factored out, that becomes my other factor. So now these are the factors that will give me x to the 4th plus x squared minus 20. Now I still have to ask, can this be factored anymore? And the answer is yes. X squared minus 4 can be factored again. So I'm going to rewrite x minus 4 as the difference of squares. So I take the square root of the first term, I get x. The square root of the second term is 2. And when I do the difference of squares, my factors will be conjugates. And then x squared plus 5, it looks like it might be the sum of squares, but 5's not a squared number, so I can't factor that anymore. So then this is my final answer for this example A.